90-degree angle. That's exactly right. A right angle is any 90-degree angle, and it's just that simple. Any angle that's 90 degrees is a right angle. What does that look like? Well, it looks like an L, as we've seen. And we draw that little square on the angle, just so we know that it's a nice, perfect 90-degree angle. Good so far, right?
Yeah.
Right?
Yeah.
Okay, good. After a right angle, we of course have an acute angle. Someone help me out. What's an acute angle? Yeah, Jordan.
An angle less than 90 degrees.
That's right. Any angle less than 90 degrees. All right. Classic. Any angle less than 90 degrees. What does that look like? Well, it looks like an angle that's less than 90 degrees. Something like that. So we see that our L that we had with a right angle kind of starts to flatten a little bit. We could think of it like two hands of a clock going towards each other, and eventually they're going to overlap. But an acute angle is before that overlap happens, if you get what I'm saying. What's the opposite of an acute angle? Obtuse angle, that's right. Obtuse angle. Who can tell me what an obtuse angle is? Go for it, Noah.
An angle more than 90 degrees.
That's right. Any angle larger than 90 degrees. What's that going to look like? Well, it's going to be a very wide angle, much wider than that 90-degree angle that we saw first. So these are the three angles that are kind of burned into our memory at this point. At least I hope they're burned into your memory. But as we saw on that booklet, the fourth type of angle here is not as easy for us to recall learning about. What's that angle called again? Straight angle, right? A straight angle. Real quick, anyone can tell me what a straight angle is? Yeah, Mason?
180 degrees.
That's right. Any angle, or we could say any 180-degree angle. And what it looks like is just a flat line. Just like that. Make sure you draw a dot in the middle of that line, just so we can signify that it's two separate rays that just so happen to be parallel like that. Quick show of thumbs, up, down, sideways. How do you feel about recalling our four main types of angles? Thumbs up if you're like, oh, I already remember this, I got this, I'm good. Thumbs sideways if you're like, yeah, they sound familiar, but now that we wrote it down, it makes a little bit more sense. I'd like to see everyone's thumbs, so go ahead and just give me a quick sign of where you're at. Okay, good. I see all thumbs up. That's exactly what I was hoping for. Now let's move on to some angle relationships, just like we saw in that booklet. The first one we're going to talk about is complementary. There's not much room here. Complementary angles. Anyone remember what a complementary set of angles, or pair of angles, I should say, is? Azalea, you remember? Exactly. Two angles that add to 90 degrees. Two angles that add to 90 degrees. So if we have a right angle like this, and we have a ray, which is just a line with a little arrow point on the end that's called a ray, Then we have angle A here, and we have angle B right here. Now, whatever A and B are, they're going to add to 90 degrees. That's what complementary angles are. Notice how complementary is spelled with an E, not complementary, right? We're not complimenting anyone. We're complementing. Does anyone, real quick, just want to check in, does anyone know, like, where else have we heard this term, like compliment with an E instead of an I? Because we all know, oh, if you compliment someone, that's spelled with an I, but has anyone ever seen this compliment with an E?
Yeah.
Where have we seen it before?
Like I see that like hotels.
Hotels, yeah, complimentary room service or something like that. Or they provide complimentary towels. In that instance, that kind of just means that it's free.
Or kind of like restaurants.
Yeah, or yeah, exactly. Restaurants, if kids' meals are complimentary after 4 p.m. or something like that. We see it kind of all over the place. There was another example that I just had that I forgot. Oh, if you have like a drink that complements a meal, you know what I mean?
Yeah.
So like complement means to go together. That's basically what I'm trying to say. These two angles go together and make a nice straight 90-degree angle. I'm just trying to break it down in simple terms here. And the opposite of a complementary angle is a supplementary angle, right? S-U-P-P. These type of angles supplement each other. Anyone ever heard this term supplement before? Supplies, good, yeah. Same root word. Say that one more time. Supplementary, yeah, like supplementary angles. What about like nutritional supplements? Anyone ever heard of that before?
Yeah.
Good, yeah. So supplements, it's the same kind of thing as complement. It just means that they go together. But obviously when they go together and add to 90 versus when they go together and add to 180, we just need two different names for those relationships. So this is two angles that add to 180 degrees. That orange is kind of hard to read, I'm sorry, but supplementary angles are going to look like this. Here's angle B. There's angle A right there. I'm going to zoom in here so you can see better. That's what our supplementary angles look like. Now in this example, what type of angle is angle A? Obtuse, exactly. Good morning. And what type of angle is angle B in this diagram, folks? Acute, exactly. Go ahead. So we have an obtuse angle and an acute angle. One is larger than 90, one is smaller than 90, but together when we add them up, we get 180 every single time. And we know that because take a look, right here is a straight angle or a flat line. Straight line, that's a straight angle. Together, that whole angle is 180 degrees. Now, I'm not sure if you guys know about these last two relationships, so let's talk about them. The seventh one we're going to mention here is vertical angles. Give me a thumbs up if you've ever heard this concept before. Vertical angles. Ooh, no one. Okay, good. New stuff. Have fun. Our last two will probably be new. Vertical angles are two angles that, I'm just going to write it in like simple words. I forgot where you're at. Good morning. She says who? Oh, yeah. That's right. You're in group 8. Thank you, Angelica. Geez, we're going to have so much time to work. Bad. Well, depends on who you ask. So vertical angles, two angles that are, this isn't necessarily the most like specific math language, but I want you guys to understand what I'm talking about. These are two angles that are directly across from each other. Two angles that are directly across from each other. It's kind of along the same lines as parallel. If we have two lines like this that intersect at some point, vertical angles would be angle A and angle B, just like that. Give me a thumbs up if you see what I mean by directly across from each other. Like that. Put your thumb up if that makes sense, that phrasing. Okay. Is anybody a little bit confused by what I mean by directly across from each other? It's okay if you are. I just want to know so I can explain. We can kind of think of vertical angles. I like to think of them like an hourglass, right? If we have, let me draw a little diagram here. If we have an hourglass, or a sand timer as they're typically called, right? So we got sand up here on the top, and then we got sand down here, right? And the sand just falls down as time goes on. You guys know what I'm talking about, right?
Yeah.
Okay. So vertical angles are kind of like the inner parts of this sand timer. We got a question over there, folks? No? Okay, thank you. So, again, it's like the opposite sides of the sand timer. You can think of anything that's kind of symmetrical like this. If you take a bow tie, this is going to be a really bad bow tie drawing, but there's a bow tie, right? Your vertical angles are right there in the middle. They're directly across from each other. So when you think about vertical angles, think about symmetry, because they're kind of like a reflection in a way. Yeah, Blake? Okay. So think about a reflection, think about sand timers. That's our vertical angles. And the last relationship is by far the most confusing relationship. So let's talk about it. It's called adjacent angles.
Isn't it like with the right next to each other?
Yeah, exactly. Okay, so we may have heard a little bit about this in Math 7, maybe even Math 6. Who knows? I don't know anything about elementary school, so. Adjacent angles are just two angles that are directly next to each other. Wish I could have made these boxes larger, but hopefully you have some room. Two angles that are directly next to each other. Yeah, Noah.
Would that be like a supplementary angle?
Exactly. This is why this idea is a little bit confusing. If we take a look back up at complementary and supplementary angles, angle A and B are right next to each other. And right here, angles A and B are again directly next to each other. They're not across from each other like we see in vertical angles. So all complementary angles and all supplementary angles are also adjacent angles. But when we're talking about specifically adjacent angles, if we were going to classify a pair of angles as adjacent angles, it would basically just be anywhere in between 0 and 180 degrees, but not 90. I just made it a little bit more confusing. Let me draw the diagram first. So if we have angle A right here, angle B right there, those are adjacent angles. They're right next to each other. They share a ray right down the middle of the entire angle. Right? It's the right side of our angle A and the left side of our angle B. So those are our adjacent angles. Now, if we made angle B a little bit flatter, we might have a complementary relationship, but they'd still be considered adjacent angles. If we opened A up a little bit more and made a nice flat line on the bottom here, Then we would have supplementary angles, but they would still be considered adjacent angles. It's kind of like the whole square versus rectangle debate, where a square, here's a square is also technically a rectangle. We can look at this shape and say that's a rectangle, because a rectangle is a four-sided polygon with all 90-degree angles. That's a rectangle. But if we have a rectangle like this, we cannot call it a square. Right? You guys see what I mean? A square is also a rectangle, but rectangles are not squares. So, how does that connect to this? Complementary and supplementary angles are also adjacent angles, but not all adjacent angles fall into one of these two categories here. Give me a thumbs up if that resonates with you a little bit. And what I mean by that is, does that make sense? Okay. If not, we'll get plenty of practice on worksheet 69 that we're going to get right now. And we've got tons of time to do it, so I'm actually going to throw another little thing in here in about 25 minutes for extra credit. So let's go ahead and get this work. Oh, sorry. Questions I can answer before we get started. Okay, cool.